In this video, we will look at thread and what is thread in Java. So Java thread is a lightweight process that executes some task. And a task can be anything. In real world, a task is remodeling a house, painting a house, and moving a couch up a stairs. And in computer world, a task can be calculating sum of 5,000 numbers, calculating average of scores of students, and doing a bank transaction, withdrawing and depositing money from one account to another account. Now let's look into the example which we just talked about, is calculating the sum of 5,000 numbers. So you are assigned this task and you come up with a solution where you say that I will put those 5,000 number in a list and then we'll loop through it and then calculate the sum. So you implemented the program, but when you run the program, you find out it took 2 seconds to run this program. And if the list grows from 5,000 to 100,000 and to a million and 10 million, then the time it takes to calculate sum is growing exponentially. So you start thinking about a solution to optimize the program so that it will run faster. So the one solution which you thought about was use a better computer with greater good CPU and higher RAM, and let's run the program on that machine. But what you find out is that when you have millions of numbers where you have to calculate sum, the performance was not optimal. So you start thinking about another solution, and it come in your mind that maybe why not I just break this task into multiple tasks and do divide and conquer, and in this way I can optimize this and optimize the performance of this program. So you divide the list into two lists, or you split the list into two lists, and calculated the sum of those lists individually, and then afterwards sum the results, and you find out that you have decreased the time it runs to nearly half. So you really like the approach, and you said that maybe instead of doing it and splitting the list into two, maybe I should split the list into 5. And you split the list into 5, and then it reduces the time of running this program even more. So this is what is called multi-threading in Java. Multi-threading is a Java feature that allows concurrent execution of 2 or more parts of a program for maximum utilization of CPU. And why threading is used in Java? Threads are used in Java to make application run faster by doing multiple things at the same time. So example of single thread. So single thread is the smallest unit of processing. There are two types of threads, user thread and daemon thread. When an application first begins, a user thread is created. From this thread, we can spawn as many user and daemon threads as we need. And daemon threads are used for cleanup tasks in background, and Java used them for garbage collection. Now let's look into this simple program, which is an example of single thread. So in this program, I just have this public static void main method, and I'm just running out single thread is running. So this is an example of single thread where we are executing some task. And the task in this case is printing out single thread is run. Now let's look into multiple threads. Multiple threads run in parallel to each other and share common resources like CPU and memory. So when you run multiple threads in Java, it's a JVM with combination of operating system defines how this program will run. If you're running it on only one CPU, then it will be running those threads in time slicing mode. If you have multiple cores of CPUs or multiple CPUs in the machine, then the threads will be distributed to multiple cores. And we will see in our future section that how we can split this, or how we can give these tasks to multiple CPU cores or CPUs. So I have created a simple program, and this program is multiple thread, and here I am creating two threads, and then thread initializing them with their name, new thread thread 1 and new thread thread 2. And then afterwards I am starting those threads, and then I'm just printing out the name of those threads. So when you do thread 1.start and thread 2.start, you are giving the instructions to the process that when the CPU is available, start running those threads. Now thread life cycle. So when you create a new thread, it is in the new state. So it is not running, it is not blocked, it is just in the new state. And when the instance is invoked with the start method, the thread control is given to scheduler to finish the execution. And then when the thread starts running or executing, it is in the running state. When the thread is blocked or is temporarily inactive because another thread has a lock on the object which this thread is trying to attain, then the thread is in a block state. And we'll discuss this in more detail in our future sections. Now waiting state. So there are two waiting states. One is the time waiting state, where we are calling sleep inside our program, and the other waiting state is where you're waiting for notification from another thread to start resuming, and the final state is the dead state, where the thread is terminated. A thread does not have to go through all the phases of life cycle. So starting from new, it can be runnable and then running, and from running it can go directly to dead, or from running it can go to waiting or blocked, and from blocked to dead and then waiting to